Okay, hi there. Thanks for your interest in modStack. This video is just going to take you through a little bit more and introduce you to it, and so you understand exactly what it is, and to see if you'd like to learn more about it, which I'm sure you would. It's a fantastic idea. So my name's Tom Medhurst. I'm the founder of modStack. I'm also a product director of a security software company based here in the UK. That role requires me to be responsible for the architecture of the system, the Q&A, the engineering and the product roadmap. So some of the areas which modStack really kind of concentrate on, these are areas that I really need in my job every day. I've got 10 years commercial experience developing solutions, but these aren't just small solutions that you see in other examples from other products. This is big data, many millions of transactions, sometimes a minute, sometimes a second, in very high security areas. I've worked for the British Ministry of Defence doing software solutions. So in those cases, sometimes lives can be at risk if there are flaws in the software. So it's really important to get high stability software that's tested very well before it goes out into the field. Another area that I've worked into is scalability. I've worked in telecoms. Anyone in that area knows that you need to be able to process data very, very quickly and very high bulk. So some of the customers that I've worked with in the past: Verizon Business, Bell Canada, British Telecom, McDonald's, British Ministry of Defence, that was in the area of anti-terrorism, French Telecom, the Turkish Guaranty Bank, and a lot of the UK police forces are using security software that I have written and designed, and that actually use the modStack design underneath. So first and foremost, modStack is not a product. I'm not trying to sell you anything. It isn't a revenue generator of any sort whatsoever, so I want to be transparent there. It is a boilerplate, platform-agnostic software architecture design. It's made up of lots of different design principles that you'll read about, things like test-driven development, things like solid design principles, dry. They're all kind of encompassed inside this one product, and I've kind of branded it because it's easier to talk about with a name, but it isn't one thing. It's a collection of different things. But when you adhere to the rules that are documented in the modStack versions, you should find that the software that you're developing is more stable, it's very scalable, and is much easier to maintain. So when you get a much larger code base and you're not just looking at smaller programs that have, say, thousands of lines, we're talking hundreds of thousands, even millions of lines of code, you don't feel like you're kind of cobbling bits on top of each other like a Lego, and it becomes more and more unstable the more you add. This is something that you constantly reaffirm the quality of it, and you continue that quality on and on and on, so the product only gets better rather than more complex. The website for modStack, I will admit, is still quite in its early stages. There's a lot of documentation to do. modStack itself is very mature. It's been running in the world, for want of a better phrase, for a very, very long time. But its documentation is still quite young. On top of these design principles that we're talking about, things like dry and solid and test-driven development, behavior-driven development. This is actually a practical implementation as well, so I'm going to show you how to apply those. And this is something that I felt was really missing from some of these principles. They are written at a very generic level. They're written in ways that are kind of designed around the theory and not the practicality of implementing them. And you're kind of left to your own devices to try and understand those and how to implement those in for your product itself. So I'm going to show you with the modStack how to do those implementations. You can get started right now going straight to the website and looking through the documentation there, and there will be some practical applications, and there'll be a lot more of that coming. This particular presentation, I'm just going to concentrate on just introducing you to modStack and what it is. And because modStack isn't a product, it can't be sold, it can't be wrapped in commercial licenses. It is free for you to use. The information will be out there, is out there, and you can use this in commercial products. There's no licensing because there's nothing to license. So this is all free for you to use. So the fundamentals of modStack is the concept of a workflow between modules using messages. Now modules are a grouping of code that is isolating a particular functionality or responsibility or technology as well. I've written some blogs in the past, and you can check those out on the modStack website as well, about surviving picking the wrong technology for a particular solution. So you want to go down you've decided you're going to use MySQL particularly for a database, let's say, for an example. You go down the road, you kind of embed that SQL right into your code, and then you realize that actually MySQL isn't for you. It's not really the right choice for this particular solution. You need to swap it out with something like Postgres, maybe Microsoft SQL, because you're going down the Microsoft route. The problem is that if you don't isolate particular technologies away from each other, then you're going to have a problem when you come to swap them out, and you need to be able to take a unit of work that has a technology and take it out without having to change any of the code that has anything to do with anything else. So this very simple example is a workflow for a product that takes files from a Samba file drop. They extract the data that's in those flat files, so they're CSV, and then stores them inside a database. So a very simple workflow. Problem is, if you wanted to change the database to, say, MySQL or a no document database, then chances are that you're going to have an impact on the code that runs in the Samba file drop, maybe the CSV extractor. But this design allows you to completely take those away from each other. So there's a concept of modules and there's a concept of messages. So some of you will be familiar with something called domain models. These are classes that contain properties that are around your code. So let's say, for example, your CSV file contains a structured set of columns, and you're taking the data out of CSV and you're putting it inside a domain model. So the domain model may have three properties on it. One is the date, one is the second column from that CSV, and the third is a third column from the CSV. And you actually you statically type those, so you've got properties with names that are compiled into your code with those column names. Well, the problem is that if you change one of those, if you add a column inside your CSV data, or if you want to rename them or anything like that, you have to change that domain model. Well, the problem is if the domain model is being shared between different modules, and let's say for argument's sake your product is big and it's a lot more complicated than the workflow in front of me here, then that change to that domain model has an impact on every single module. And what we're trying to do is avoid that. So you can change something small in one area and it not affect the other modules. And that's exactly what we do. So templates, I've called them templates in modStack because actually they're called different names in different technologies. And remember, we're going to be technology agnostic here. If you're familiar with Java or you're familiar with C# and the .NET framework, you'll know the word interfaces. So interfaces are an amazing part of programming. You should definitely be using them all the time. They're really useful because they're like a promise of behavior. So they can tell you what something can do without actually telling you how it's being done. And you can move these around and you can interchange things very easily without having to worry about base classes and changing things like abstract classes. These are fantastic pieces of kit in your toolkit, and you should be using them a lot. So the templates show you what can be done. The implementations show you how they can be done. So this is things like a Postgres database module which stores data inside a Postgres database. So you have that implementation. The thing is, you could be saving very different data between different customers. You could be saving data into NoSQL based columns. So you've got the new JSON and JSONB columns in Postgres. You've got XML column type in other areas. Oracle, you have your own. You can create your own custom types for Oracle databases and Postgres as well. So there's a lot of specifics to your particular program, and that should absolutely go into configuration. It should be kept away from your module implementation. So your module just concentrates on implementing the technology in a way that is compliant with modStack, and everything else is down to configuration. We've got some really powerful configuration designs in here. They are based around and somewhat reliant on the type of dependency injection that you use in your product. If you don't know anything about dependency injection, then have a Google around. ModStack, we absolutely insist on dependency injection, but we don't tell you how to do it and which particular technology you use. So it's up to you which technology you use. So it's kind of bring your own dependency injection. And that's really great as well, because you can keep that modularized and keep it away from the product. So if you find one particular dependency injection library doesn't actually suit you, or you come down 6 weeks into a development phase or a sprint, and then you realise that it actually isn't for you, then you can take it out and not have to worry about all the other work. But you've got to do it properly to be able to get that. But that is a great way of doing it. The other thing about the workflow for ModStack is that exception handling. Now, exception handling is very, very difficult to do. It's a very complicated area, but if you don't do it properly, then you're going to have some bad stability issues with your product. You can't go around capturing every single exception, because your product is going to end up in a state that you don't understand in runtime while a user's using it or a server's interrogating it, and that's going to create instability. And it's also going to create a ripple effect whereby something else is going to break further down the line because of this problem. It's going to be much harder to debug the actual cause of it. So what we have here is when an exception is thrown inside your module, you don't handle it, but the message routing mechanism does, and you can configure a route in which it's taken for that error. You could write that to a file, for instance, and that error exception information and the original domain model or your message between those is captured as well and stored on wherever you want to. It gets moved with this workflow, and you can keep this away from other modules, and you can each module handle errors differently, so you can really work well with exceptions. I use a lot of server-to-server systems whereby there's no user interaction, and the real problem with server-to-server is sometimes you need a human brain to look at stuff, and it's very difficult for a computer to know, is this a transient problem? Is it a permanent problem that I need to be able to handle? Do I retry it gracefully? How do I fail? And sometimes the best thing is to take that exception that's being handled, write it into a table, and have an actual human look at that and review that using an interface as well. So that's another kind of option. But having the ability to not have exception handling as a side part or a aspect within your code, but having it as a part of your workflow, so it's configurable behavior, so you can change the behavior after you've deployed this product as well. So it's a really great idea. So what is a module? As a programmer, what are you looking at? Well, it's a very liberal template. It's very small. It's designed not to be restrictive, so you can continue writing your modules however you like. You can create a new thread when you set up your module and run everything in your thread. You can have it single threaded as well. It's completely up to you. The idea is for this to be completely future proof, and whatever technology you want to add into a module, or whatever reason for creating a module, you're going to have one interface that's going to work with everything, and that's why it's so short. So we've got a module here that just has a setup and tear down, and so create and destroy functions, very much like a unit test. They are given a copy of this message router, and that gives them the ability to subscribe, unsubscribe, and also emit messages between different modules, and that's all they know about. So they're taking a message and sending it out blindly, so they don't know the other modules, nor should they know. They just concentrate on this. So this is isolation of responsibility, which is really key. The other possible extensions into your module can happen via the constructor, which isn't in the interface, and this is where your dependency injection really comes into play. You can also use properties as well. A lot of dependency injection technologies allow you to set properties via configuration. So your module can act and behave exactly how you want it to. You can extend it using these templates further, but that's not part of the scope, and nor should it be of a module itself. So this is what it is. Now, a module doesn't receive messages, a message listener does. However, your module will probably be a module and a message listener, so this is taking advantage of most programming languages whereby you can implement multiple interfaces. You may know them as mixins in your language if you're using some of the more modern dynamic languages. But a message is very, very simple. It just has a timestamp, a message type, and a payload. Sorry, that presentation says member name. That should say message type. Sorry. So every message has a type, and if you look at subscribe and unsubscribe, you can see they have a string. That's the message type that's being emitted, so you can subscribe to particular message types. You can also use wildcards in later versions of modStack, so you can subscribe to something and you can use suffixes or prefixes to be able to capture multiple different message types, which makes your configuration much simpler. So just an example of what that looks like and how simple that is. Here's an implementation in Java. The message is probably the most complicated, although it's not really. We've got a message type, we've got a precondition there that just makes sure that you're not going to pass it an empty string or a null message type, but then you're setting up the timestamp and the payload, and then you've got some getters and setters. The other bits are the module here, which has the setup and tear down, the message listener, which has the message received. So, as I said before, your module will probably implement both iModule and the iMessage listener. So you're going to have about 3 functions which are set inside your module relating to message routing. We then have this message hub, which is going to be responsible for catching your exceptions, but also subscribe, unsubscribe, and emitting your messages. So that's where the real magic happens. But that is a very simple. I've implemented that in under 300 lines of code, and that's where your unit testing comes in. You notice here that you've got very, very little code to actually be unit tested. These interfaces can't be unit tested. The message system has 4 lines of code, 5, 6, 7, 8 lines of code there that can actually be unit tested. So your base class library, very simple, and is just reliant on your implementation thereof. So I've talked about a logical separation of responsibilities, whether that's technologies or actual aspects like logging and things like that. You can also wrap modules inside logging and performance counters. Because you've got that isolation, you can wrap this with other code. You call these decorating in a lot of languages. It's a good technique to use. That way your modules aren't filled with logging and other code that's used for debugging. You can keep them clean and just concentrate on that technology. So modules really do one thing well. They usually implement a technology, but they should be completely generic when it comes to decision making and the way in which it works. And that allows you to use a single module for multiple clients that you have that want a system to behave in a very different way. Again, we're going back to the Postgres example where you could have statically typed columns that are well defined, or you could have XML and JSON columns which are kind of NoSQL based, so you can use those. That shouldn't be inside your implementation. That should be configuration. A module should be open for extension but closed for modification. This is one of the big laws of solid design principles. This is talking about writing everything and finishing a module so it's complete, but allowing more templates. This is where your dependency injection comes into play, so you can extend the way that module works without actually changing it. You can also do things like superclasses and deriving the code within your module into a new class and using that as a module and configuring that so you've got different versions of your module and behavior, and versioning all comes into that. It's all taken care of. It's really quite all-encompassing modStack, as you can see. The configuration, as I said before, it controls the data flow in the module's behavior. It's your business logic goes inside your configuration, because customers change their mind, they're a pain in the bum, but they're always right, and you should be able to change that really quickly. But also this puts the responsibility more on professional services as opposed to your development team, so that you can free up your development team for writing, doing what they actually should be doing. The domain models, beg your pardon, should just be name value pairs. They shouldn't be strongly typed classes, because you're going to have to start redeploying all your modules when you make a change to your domain model. If you can route things through and configure the properties that other modules are interested in, then actually you don't need to worry about new columns coming into a CSV file, as we talked about earlier. This is all happening in configuration, and you don't have to redeploy assemblies. The idea is that you can fix a module, you change the behavior of a module, and you just redeploy that one assembly that contains that module. And it's proper isolation and separation of responsibilities, and it's done well. And again, bring your own dependency injection, so you can bring whatever technology you like. There are other technologies out there. If you're a Microsoft.NET developer, then check out Unity. It's a fantastic library that Microsoft write. I've also written a YAML configuration layer on top of that. You can search Coplex for Unity YAML, and you can see a really nice, easy to use configuration mechanism built on top of the Unity dependency injection. So your professional services team can do that work. So that's the introduction, really. I really hope you found that interesting and you want to learn more. Please jump on the website, have a look through. There's more stuff coming, and have a chat to me on Twitter, modStack EU. I'm on there all the time, really happy to chat to anyone. I'm really open to, if I've got something wrong or I've missed something, or if I haven't experienced something in my programming career that maybe you have, or you've got some questions about how this fits a particular project, come and chat to me. I won't bite you, I promise. Okay, so I hope you've enjoyed that. Thank you very much for your time.